Let's take a look at review problem 4.2. We have a population. The average height is 71, the standard deviation is 3, the average weight is 182, the standard deviation is 35, and the correlation coefficient is given to be 0.52. First question is to predict the weight of a man who is 68 inches tall. To do this, we find the regression line. The equation of the regression line would be y is equal to beta hat, or beta 0 hat, plus beta 1 hat times x. And there are two ways of finding the betas. In this case, the easiest way of finding the betas is that beta 1 hat is equal to r times s sub y over s sub x. The standard deviation of y divided by the standard deviation of x. R is equal to 0.52. S sub y is given to be 35. And s sub x is given to be 3. So we note that I'm trying to predict height, or trying to predict the weight knowing the height. So that means that heights are the x's and the weights are the y's, because the height is known but the weight is unknown. So that is the way the formula goes in that case. More on that later. So there's my beta 1 hat. And that works out to be 6.06666 repeating. Beta 0 hat, the intercept, is given by y bar minus beta 1 hat times x bar. So the average of the y's is 182 minus the slope that we just got, 6.0667 repeating, or 666 repeating, pardon me, times the average height, which is 71. And so doing that, we get that the intercept is equal to negative 248.73 repeating. Okay, so there's our regression line, so that y is equal to negative 248.7333 repeating plus 6.06666 repeating times x. And so for part 1, we just simply plug 68 into this and see what comes out. So plugging in 68, so 6.06666 repeating times 68 minus 248.7333 repeating works out to be about 163.8 pounds. And so that would be the predicted weight, knowing the height. Part 2, predict the height if you know the weight. And this should be who weighs 200 pounds. The mistake would be to do the same thing we did in part 1. Here's the equation. For part 1, we plugged in 68 into x, and we got the y. For part 2, the mistake would be to plug in 200 for y and solve for x. The reason that's a mistake is because the role of which one is known and which one is unknown got switched. So we will have a very similar equation to what we just did, except the roles of x and y get reversed. Our regression line will be x hat, or x, pardon me, is equal to beta 0 hat, a new beta 0, plus beta 1 hat times y. And this time, beta 1 hat will be equal to r times, not s sub y over s sub x, but the other direction, s sub x over s sub y, because the role of which one is known and which one is being predicted have been switched. That's 0.52 times 3 over 35. So 0.52 times 3 over 35 works out to be 0.006 0.04457. And then finally beta 0 hat. Before it was y bar minus beta times x bar. Now it'll be x bar minus beta 1 hat times y bar. Again, the roles of x and y get reversed. So 71 minus the thing that we just got, times the average of the y's is 182. So we do the arithmetic, and we get that the answer is 62.888. So our regression line is going to be equal to, x is equal to 62.888 plus 0.04457 times y. So finally I plug in 200 into this, and let's see what happens. So 0.04457 times 200 plus the 62.888, and we get a predicted height of 71.802 inches. So there is the predicted height if the weight is known to be 200, and here is the predicted weight if the height is known to be equal to 68. So it's the same equation both ways. We just have to be very careful about knowing which one is the known and which one is the unknown.